So about halfway through my long division video, I realized it was going to be a real long video. So I ended up separating the two videos. That way we had the freedom to kind of learn one method one day and the other method the next day. So this video is just going to cover synthetic division of polynomials. So if you're looking for long division, go find the long division video. It's probably called 5.4 part 1. So synthetic division, the word synthetic means fake. So we're not actually dividing in synthetic division, because if you think about math, like the two hardest operations when you're a little kid are dividing and subtraction. And that's all like pretty much long division is, a little bit of multiplication too. So mathematicians are like, well, instead of dividing, we can rearrange that as a multiplication, because they are really the same operation. And then instead of subtracting, we can turn it into an addition problem. So in order to do that, we have to kind of set it up really weirdly. This is the setup. There's like a weird half box, and then there's some space, and then a line. So what goes in this half box, and these are your notes, so you want to take good ones here. This is the solution of the divisor. This will make more sense in a minute, okay? That's what goes in that little weird half box. Then, along the side of the half box here are the coefficients. I can't fit this in. The coefficients, I'm going to say in SF, which means standard form. Again, that'll make more sense in a minute. And then underneath this line here, we are going to do some work, and we're going to come up with the coefficients of the answer. So underneath that line is where we're going to end up seeing a part of our solution, and then we get to interpret that solution. That's kind of the catch in math. You know, you're going to come up with an easier way to get the problem done, but the interpretation of what your answer looks like is kind of the tricky part. So in the box here, we're going to put what's called the solution to the divisor. So this guy right here is the divisor. So the solution to the divisor would be if you set it equal to 0 and you solved it. So adding 3 to both sides would give you x equals 3. That's what goes in the box, okay? I know you're looking at that going, oh, I just take the opposite. Well, that's because you're solving it. You're setting it equal to 0 and you're adding 3 over. Don't just think the opposite, because it's a little more complicated than that in some problems. So now we're going to take our dividends coefficients in standard form order. So this is your dividend. I don't know if I spelled that right. Story of my life. First, I check that it's in standard form. It goes 3, 2, 1, 0, meaning 0 for a degree. That's standard form all the way down to the constant. So I'm just writing the coefficients. Remember, there's a secret 1 in front of this one. So the coefficients are 1, -2, -10, and a -15. So that's what the setup looks like for synthetic division. Solution to the divisor, coefficients of your dividend. Now it's muscle memory, I guess. So you start with your first coefficient, and you bring it down all the way underneath the line, and that's going to kind of get our party started. So Mrs. Meyer is really good about this. If you want to write this down in your notes, I think it helps. Any number that is below the line means it's about to be multiplied. So she puts like a multiplication dot. And then anything above the line means it's about to get added to something. So I think that helps with our notes, okay? This is going to get real weird, but after you do a couple, you'll get used to it. So 1 is below the line, so that means we multiply it by something. So the thing we're multiplying by is that 3 that went in the box, okay? So 1 times 3 is 3. I'm going to do that in black, I think. And then now these numbers are above the line, which means they get added together. So I'm going to draw a little line separating these so they kind of look like columns. -2 plus 3, we're adding that together, and then we get a 1. And then you just repeat the process all over again. So 1 times 3 this time is a 3 again. Oops, I meant to put that in green. And then we add that column together, and we get a -7. And then you do it all over again. So -7 times 3 is -21. And if you were to add this column together, maybe on a calculator, negative 15 plus negative 21 gives us negative 36. So that's all the math you have to do. Now what we have to do is interpret the solution, because you're actually staring at your solution here. What we have here, these are the coefficients, ugly, to the answer. Except this last number right here, this is always the remainder. This guy right here is the remainder. So what the heck does that look like? All right. Well, think about this problem, guys. All the way back to the original problem. We started with an x to the third, and we divided it by an x to the first. So if you started with something that had an x to the third, think long division, and you divided it by an x to the first, that leaves you with an answer of x squared at the very first term. And that's what we do, is we kind of stick variables on the end of these coefficients. So this guy right here becomes 1x squared. And then you kind of move down the line. So 1x squared plus 1x minus 7, because that would be the constant. And then think about our work with long division. How do we write a remainder of negative 36? Well, you can either say plus negative 36 over, now think back all the way to the beginning of the problem. Who were we dividing by originally? Who's our divisor? It was the x minus 3. So that, yuck, is your quotient. And same as yesterday, guys, we can, instead of saying plus negative, you can just call the subtraction sign. I don't know, was that easier? Some kids adamantly say yes, much easier, much easier. And some of you aren't sold yet. So let's do a few more examples, and let's see if you can develop a little muscle memory with how we perform the operations and then interpret the solution. The quotients, I should say. All right, so what goes in the box? Well, we got to take our divisor and find your solution to the divisor. So if you were to take x plus 6 and set it equal to 0, you would get x equals negative 6. This is what goes in the box. Then we take our coefficients of our dividend. Make sure it's in standard form order. So 2, 1, constant. That's it. And the coefficients, remember there's sneaky ones in here, right? We got a 1, a negative 1, and a negative 42. Okay, I'm going to write a couple things here to remind me. If it's below the line, we're going to multiply something, and if it's above the line, that means we're adding something. But in order to start this division party, we need to bring down our first coefficient. Okay, the other thing I would like to add is little column lines here, so I can kind of see what's going on. Here goes, guys. Number 1, it's below the line. Multiply it by what's in the box here. 1 times negative 6 is negative 6. Then we're going to add those numbers together because they're above the line, and we get negative 7. And we do it all over again. So negative 7 times negative 6 is a positive 42. And then if we add those together, we get a 0. So remember what this means. These guys right here, these are the coefficients to my quotient. Specifically, let's talk about this guy. Remember, that's the remainder. So in this case, we don't have a remainder, so we won't have to have that weird fraction thing. And now I got to go back and think about the original problem. I had an x squared originally, and I divided it by an x to the first. So that would have left me with a quotient of x to the first, at least as the first term. So that's what I put down on this first one here. You have 1x to the first, and then the next thing would be a constant, so minus 7. And because I have no remainder, I don't need to write that fraction. So y'all, your solution, I shouldn't say your solution, your quotient is x minus 7. So the interpretation, I think, is the hardest part for sure. All right, I think we got one more plus something else fun. All right, so number 6, we have to look at our divisor and think, okay, what's the solution to my divisor? My solution to my divisor would be x equals negative 2. That's what goes in the box. Then we line up our coefficients in standard form. This one's a little tricky. It starts off with cubic. It goes 3, 2, 1. Do you notice how we don't have a constant? So what you need to remember is you have to go all the way down to the constant. You're going to have to put 0 there as a placeholder. So my coefficients are 2, 6, -9, and a 0. A really good way to double check that you have enough terms in your setup, whatever your degree is, you should have one more than that. So if you have a degree 3 dividend, you should have 4 terms set up in that after the box. If you have a degree 2, you should have 3 things set up. If you have a degree 5, you should have 6 things set up because you need all the way down to the constant. Okay, I know I got to bring that 2 down to get this started, and then it's going to be a series of, if you're below the line, multiply, and if you're above the line, we're going to add. The other thing I like to add are my little breakups with the columns here. All right, let's see what we have here. So 2 being multiplied by the box, 2 times -2 is -4. And then these above the line here, we're going to add these together. 6 plus -4 is a 2. And you do it all over again. So 2 times -2 is -4. And right here above the line, we're going to add these together, and we get -13. Then -13 times -2 is +26. And if we add those together, we get 26. So I'm going to mark up a couple things here. I know that this guy here, this last part is my remainder, so we are going to have a weird fraction thing. And then I think about, okay, what did I have at the beginning of this problem? I had a 2x to the third, and at the very first level, I divided it by an x to the first. So that would give me a 2x squared as the leading term to my quotient. Now watch this. You already have the 2. So I'm just going to stick the x squared part down there. And then I'm going to move down the line. So 2x squared, this would be a plus 2x. This is our constant. And then for funsies, I got to write that weird fraction thing for the remainder. So we have plus 26, who is still being stuck in a division problem of x plus 2. Yuck. All right, so that's synthetic division. Definitely has less like work than long division. Very weird work. And then you have to interpret the answer. So there's drawbacks to both. And like we said in the long division lesson, you're responsible for both. So it doesn't really matter if you like one or the other. You got to do both at certain times. This question is actually kind of leading us into a lesson that's coming up soon. And Fundamental Theorem of Algebra and graph interpretation and solution determining. That's a good time. So let's just give you a little teaser here. If I have a function, this is it. It's a cubic function. And I want you to factor that. Well, the only method you guys have for factoring this is factor by grouping because it's 4 terms, and you can't group this one easily. So another way to factor is to use what's called the Fundamental Theorem of Algebra that states if I can give you one of the roots or solutions, you can use division, or synthetic division in our case, to break it down to a smaller polynomial and then use another technique after that. So let me show you what that looks like. Notice here they said x equals -2 is one of the polynomial zeros. This is what goes in the box. So you don't have to do any like solving or opposite. It's already solved. So when I set up synthetic division here, the -2 goes in the box. I still set up my coefficients like I did before. So we remember there's a sneaky 1 here. So 1, -5, -2, and a 24. Leave a little space here, like at least a line, right? We know we're going to bring down that 1 to start everything. And remember, if we're below the line, we're multiplying by the box. And if we're above the line, we're adding the column. So, here we go. Let's do this. 1 times -2 is -2. When we add those numbers together in the column, we get -7. -7 times -2 is 14. And then when we add these together, we get a 12. And then 12 times -2 is -24. And then this is what was supposed to happen. If I'm plugging in or evaluating at one of my polynomial zeros, it's supposed to go in evenly, which means there's no remainder. And as you can tell, we're getting no remainder, which is awesome. Means I've done something right. So you might be asking yourself, like, well, what was the point of this? So now what you have the coefficients to a smaller and reduced polynomial that is kind of a cousin to the original one. So I had x to the third, right? At the beginning here I had x to the third, and I was dividing it by one layer, so I'll just call it an x, which breaks it down to an x squared. So this coefficient belongs with an x squared minus 7x plus 12. Hey, and they asked me to factor this. Guys, we can factor that. That's a simple quadratic trinomial. We got this. So this guy, if I just use my normal trinomial factoring technique, I end up with x and x. How about a -4 and a -3? Those would multiply to 12, and they would add up to -7. But remember, at the very beginning of this problem, they gave me like a little hint. They said x equals -2 is one of your zeros, which means if you reverse solved it, that's a weird way of saying it, you would have your factor. Now, if this is kind of confusing to you guys, don't panic. There's a whole lesson on this coming up next. This is just kind of a teaser, if you will. So x equals -2. If you think backwards to that, the factor that produced x equals -2, wouldn't it have been x plus 2? So my true factorization of the original problem is that. So the x minus 4 times x minus 3 came from my reduced polynomial. And then this x plus 2 came from that giant hint they gave me at the beginning of the problem. Wow. That was a good time, I know. Okay, so that last question, number 7, if that was confusing, just kind of etch-a-sketch it from your brain, and we'll rediscuss that when we talk about 5.6, which is Fundamental Theorem of Algebra. But everything before that, the synthetic division, that's something I'm going to need you to perform independently coming up here on practice work, okay? Good luck, everybody. I know that was a weird set of lessons just now. Good luck.